A very good morning to all of you students of class 10. I am going to start the second video of this chapter, magnetic effect of electric current, from the Oersted experiment. Oersted was the scientist who has already discovered the magnetic effect of current. Magnetic effect of current was accidentally discovered by H.C. Oersted in 1820. Before this discovery, electricity and magnetism was considered as two separate branches of physics. Now it is studied as a one branch, that is called electromagnetism. First of all, I am going to start an experiment done by the Oersted. In this experiment, Oersted observed that when an electric current flows in a wire, the needle of the compass deflected. The needle of this compass is always showing the deflection itself in a small magnet. A magnet can be deflected only by a magnetic field. So Oersted concluded that an electric current flowing in a wire created a magnetic field, and this deflected the needle of a compass. Oersted also found that by changing the direction of the current, the needle deflects in the opposite direction. So what is the activity done by him? He set up a circuit and the magnetic compass is kept just vertical below the wire, and the direction of that wire is along with the north-south direction. When he pressed the key, he found that the current flows in the conductor or the wire which is showing south to north in direction. The magnetic needle placed below the wire deflects towards the west, that is, are perpendicular to each other. The result can be remembered by the words snow. Snow, that is a current flow from south to north and then north to south, that shows the needle deflected towards the west. When he connected of a battery are reversed, the current in the wire flows is reverse, which is from north to south. In this case, the deflection of the needle is towards the east. So Oersted found that by changing the direction of current, the needle deflects in opposite direction. He concluded that an electric current flowing in a wire which is created a magnetic field which deflects the needle of a compass. We have to learn about the magnetic field which is around a straight current carrying wire. We have said that a conductor is actually shows us by this. We can say that a magnetic field by a current carrying wire. When the current passes through the straight conductor, the magnetic field around it is in the form of concentric circles with the conductor at a center. If we place a magnetic compass, we can find out that needle of a compass oriented as shown in figure. This shows the current and the magnetic field lines. So we can say that the magnetic field due to the straight current carrying conductor having when the current is passed through the straight current carrying conductor, a magnetic field is produced around it. Using the iron filings, we can observe that they align themselves in the concentric circles around the conductor or the wire. So we can say that magnetic field produced by a conductor is at a distance r in the vacuum is always proportional to the current I and inversely proportional to the distance r. Some of the forces are also given in a straight current carrying conductor which is placed in the magnetic field. This force on the straight current carrying conductor is mutually perpendicular to the magnetic field. Perpendicular to magnetic field and the direction of the current. So we have to know about it by using a law, that is a finding direction of field is given by right hand thumb rule. So this is a simple method by which we can find out the direction of current as well as the magnetic field lines. This is a name of right hand thumb rule. So here it is given that if we imagine to hold a current carrying conductor in our right hand with our thumb straight and pointing in the direction of current. I have to repeat. If we imagine to hold the current carrying conductor, that is a straight wire, in our right hand with thumb straight and pointing the direction of the current, the direction of the curled fingers, four their fingers are representing the direction of magnetic field lines. These are the magnitude of magnetic field lines. Okay. So this is known as right hand thumb rule. It always shows us that it has a thumb which is showing the upward direction of the current, and the concentric circle shows the magnetic field around the straight current carrying wire. If a straight current carrying conductor is held in the right hand in such a way that the thumb points along the direction of the current, then the tips of the fingers or the curl of the fingers shows the direction of magnetic field line around it. These are the shown by this. This is a concentric circles around it by using the iron fillings. So we can say that by this experiment we find the strength of magnetic field at a point increases with the increase of magnitude of current. If it is showing through the wire, the strength of magnetic field can be decreases on increasing the distance of the point of observation from the wire. So we can say that SI unit of strength of a magnetic field is represented by the Tesla capital T. We have to learn about the Fleming's right hand rule. In the Fleming's right hand rule shows us that the thumb, forefinger, middle finger of a right hand are stretched to the perpendicular to each other. Okay, these are showing us that the thumb, forefinger and the middle finger of a right hand are stretched to be perpendicular to each other. As indicated below, if the thumb indicates the direction of the movement of conductor, forefinger indicating the direction of magnetic field, and the middle finger shows us the direction of induced current. So you can see that there is a thumb which shows us the motion of an current. Magnetic field shows how by the forefinger, and the current showing by the middle finger. So the magnetic field due to the current carrying straight wire depends on the magnetic field produces inside it and the distance between it, and the direction of magnetic field is always found by this rule. Magnetic field is created not only by the straight current carrying wire, but it can be calculated or produced in the case when wire is also bent. So by this Fleming's right hand rule, we have to find out that the magnetic field lines are representing by four fingers, induced current which is produced in the current carrying wire or conductor in the shown by center finger, whereas the motion of the conductor shows us the thumb. So students, you have to practice it very well, that you have to place your thumb, forefinger and the center finger in such a way that all are equal to perpendicular to each other, and then you have to know about the direction of the current by Fleming's right hand rule. It is very easy to learn. You need to only learn about the forefinger, center finger and thumb showing the direction of magnetic field, induced current and the motion of conductor. Third one is that Fleming's left hand rule. This Fleming's left hand rule is shown by the left hand. As shown already, that thumb shows the motion, forefinger shows us the magnetic field, whereas the middle finger shows us the current flowing in the direction of conducting wires. Fleming's left hand rule states that the direction of force which is applied to the current carrying wire is always perpendicular to the both the direction of current as well as the magnetic field. This shows by the diagram that the force is shown by the thumb and the middle finger shows us the magnetic field, whereas the middle finger shows us that it is a direction of current. So the direction of the force can be given by Fleming's left hand rule. If you will stretch the thumb, the forefinger and the center finger in such a way that your left hand are showing these are perpendicular to each other as shown in the figure. When the forefinger points to the direction of magnetic field, middle finger shows the direction of current. What is current? Movement of the positive charges from the negative to positive. Then the thumb points to the direction of force or the motion of conductor. So first we have to orient our hand. Such a forefinger points towards the magnetic field. Then you have to rotate your hand such a way that the forefinger remains the direction of the magnetic field, but the central finger is in the direction of motion of positively charged particles or the current, and the thumb points towards the direction of force on the positively charged particle. The force which is exerted by the magnetic field is always perpendicular by V and V. So it is very easy to learn how the Fleming's left hand rule shows us the direction of force. A force acting on the current carrying conductor in the magnetic field is shown by the direction of forces. Now we have to learn about the magnetic field due to the current carrying wire through a circular loop. The magnetic field due to the current through a circular loop. We need to know that right hand thumb rule can be used for the circular conducting wire, as well as it comprises a small strength segments. Every point on the wire carrying current gives to the magnetic field that appears as a straight line at a center. Till now, by that classes, you have learned about the field created by the magnet. The field around the magnet is a reason when we can say that it is a magnetic field. And the free flow of charges, or we can say that the rate of flowing of charges, are the current. If the wire is given in a shape of a loop, it will said that it is a circular loop. And in that circular conducting wire, we had to make a current. By that carrying current, having a magnetic field appears as a straight line at a center. So you need to learn at a center, we need to learn magnetic field appears as a straight lines. This is a circular loop when the current carrying conductor having a shape of a loop. These are the magnetic field lines. And then conductor, there you can see that the current has a two direction, where it is upward in direction and downward in direction. According to the right hand thumb rule, if the direction of the current showing upward, then the four fingers which are in closest to each other showing the anti-clockwise direction of our magnetic field lines. Similarly, you can see that when it is the current flowing from positive upward in direction, the direction of the magnetic field lines are produces around in concentric circles, always showing us anti-clockwise magnetic field lines. Whereas the current is flowing in the downward in direction, again according to the right hand thumb rule, if the current is flowing in the downward in direction, it is said that the concentric circle showing the magnetic field lines always in the direction of clockwise. Now you have to make a clear idea about it, that what is a magnetic field line shows the anti-clockwise and clockwise in direction. If the hands of the clock move from 12 to 1, 2, 3, 4, 5, 6, it shows that the direction is clockwise. When it will be reversed to each other like 12, 11, 10, 9, 8, it shows that it is anti-clockwise direction. So you need to know the arrow sign given in the magnetic field lines showing in the concentric circles are in anti-clockwise or in the clockwise in direction. The proportional relation of the current and the magnetic field lines. If the current is flowing upward in direction, always the magnetic field line around a wire which is straight is formed in anti-clockwise direction, whereas the direction of the current is downward, it will said that the magnetic field lines are always formed in the clockwise in direction, and it is proved. So when it is proved, we can say that it is shown. Magnetic field lines of the force are circular near the wire and become the parallel at a middle point M. Magnetic field produced at the center is always proportional to the current I, inversely proportional to the radius R. Magnetic field line due to the current flowing in the solenoid. Now with this solenoid is a long coil of many turns of an insulating copper wire wrapped in the shape of cylinder. You have seen the spring, you have seen the wire in the heater, you have seen the solenoid or the coil of wire in the emulsion rod, in the induction. You have seen that the spring type wire is there. So that coiling of wire is known as solenoid. With this, students, the class is over for today. Thank you and have a nice day. Hope you will learn your best and practice the figures.